All right. Good afternoon, everyone, and thanks for coming. I'm not going to introduce my guest, but I will tell you a story. So I met Danny about 2 or 3 months ago or something like this. We actually didn't know each other before, and we spent kind of almost half a day with each other, and we became friends quickly. And and myself, Danny, and his wife, Marie, and we became friends really quickly. And quite frankly, the event was in Canada. I was going back home, and I started asking myself, why did we become friends so quickly? I mean, Danny has a PhD in material sciences. I have a PhD in computer engineering. Yeah. So Craig's here. Craig is the executive director of the institute. So I was going back home, and I started asking, why did we become friends so quickly? And because we come from completely different backgrounds. He has a PhD in material sciences. I have a PhD in computer science or computer engineering. He goes to space. I go to the 6th floor. He's from a Mexican origin, and he's very, and he talks about that publicly. I am from a Middle Eastern origin, so I really didn't know why we kind of clicked that quickly. Then I go home, and I started watching his TED Talk, and it suddenly kind of hit me. Danny's motto is work hard, never give up.
Oh, yeah.
Right? My motto, which is I tell everybody in my lab, is grit. Grit is working hard for long periods of time without giving up. And then the other thing is he actually openly talks about being son of immigrants and how that affected his perspective in life. And that also kind of where I come from. I am an immigrant, and that sort of affected how I see life and I see work and I approach work. And maybe that's why we actually kind of connected quickly. So I'm going to ask you, how many people here have Netflix? That was not a very smart question. Everybody has Netflix. How many people here who have Netflix watch David Letterman's show? Okay, so I am going to steal David Letterman's title of his show. My next guest needs no introduction, astronaut Danny Olivas.
Well, and thank you to Vibal for the invitation to come and speak with you today. I've been very impressed, having been given some briefs this morning regarding the work that's being conducted here within USC. I'm here to talk about what I see as being some possibilities for AI applications in space. We'll be talking about that. But before we start, let's talk about space in general. So when we think of space, we often think that space is about Star Wars or Star Trek or Alien or Gravity or The Martian. It's very abstract. A lot of us don't necessarily get involved in space-related activities. We know there's a space program, like just by raising hands. Does anybody know what's going to happen on Monday?
Oh, you told us.
told half of the audience. So NASA is going to be launching the very first Artemis mission, Artemis 1. Its destination is the moon. It is a uncrewed mission. They'll be flying to the moon, a profile that has a number of test objectives, but essentially is the precursor to subsequent missions to the moon, which will carry human beings, which will ultimately put human beings in orbit around the moon, and ultimately doing lunar missions, not similar to what was done in the 1960s and 70s, but to prepare us for the next great human adventure, which is going on to Mars. But at the end of the day, it's a human endeavor. Space is. It's made up of people just like you and me. In fact, this is my family. That was a few years ago. You can probably tell because I have more hair, right? My wife, Marie, who's here today joining us. This is our family. Now, I have a confession to make. I have 5 kids. They're all about 2 years apart. They all went to UC schools. 2 went to UCLA, so don't hate on me too badly. Okay? We're very proud of them. I still have 2 who are going to be graduating at the end of this year. this next school year, and then one who just started at Davis. She's in her second year. So we're very excited about that. But as I said, it's very much a human endeavor. So when we think about applications of artificial intelligence in space applications, well, artificial intelligence, what is that? You know better than anybody else. It's coding, it's electronics, it is sensors, it's data, it's algorithms. It's very non-humanistic almost. It takes humans to create them, but seems rather abstract. So when we think about applications of AI to space, recognizing, of course, that space is a human endeavor, I thought the best way to get this talk started today is to show you a little bit about what a typical space mission looks like. Okay, so let's see if we can get this one here going. And what do they say, that a picture is worth 1,000 words and a video even more? And by the way, I promise none of that's on here is a deep fake.
This is cannot play media.
Let's see. Is it not going? Okay. So let's stop that for a second. While, where's the, nope. I want to just get access to the, by the way, this is being done on an Apple. I work on a PC, so there's obviously compatibility. It's the first one.
I sympathize.
Yeah.
One more.
The other one?
Yeah.
This one?
Yep, the one on top. There you go. Okay. Okay, so you can, sorry. Technology, I tell you. Computers, right?
Apple.
There it goes. Okay. I can take that. Okay. One of the things that has impressed me about being here with the team is a lot of similarities that I see in conducting a space mission and actually building a team around a central objective of trying to accomplish a very hard mission. Some of the leadership characteristics that I see that are very similar are when you're an astronaut and you're involved in space, you know, the words that you say and the things that you do really do matter. From the way that you interact with one another, a crewmate, or actual actions that you take to work on a particular problem. Those have significant consequences to the ultimate objective of trying to accomplish the space mission. But beyond the mission objective, it's also looking out for one another. And one thing that I've come to appreciate here at VMAL is the inclusive nature of the collaborations that you have here. And it's that inclusive nature that to me I think is really very inspirational. Not only does the work that you do have impact on the research that you're doing, but also beyond that, you know, the social implications on this and the implications, you know, beyond the walls of this building, you know, and, you know, you have wonderful leadership here. Wells, you know, is certainly a leader who serves his team well. And it's actually very consistent with what you need to conduct a safe space mission. Now, you saw from the video, it's a little overwhelming. Space is a lot of things. There are a lot of different aspects associated with space. I know as a researcher, I had mentioned that I got my PhD in material science. I was focused in one very narrow area of study, and that was in surface science. And so while I was studying, I thought that, you know, that was my world, and I realized how much I was able to learn to understand about one very specific area. But I think it gave me an appreciation for how much I didn't know that was outside that area. And certainly as I became involved as an astronaut and working with our nation's space program, I came to appreciate all the various facets of society that actually make up the space program. It's not just an engineer or, you know, who goes into space that could conduct this mission. I'd never flown a jet before I became an astronaut. It took people who were for fighter pilots who were able to fly the rocket and be able to bring those skills to the table. It took geologists, chemists, material scientists, mechanical engineers, electrical engineers, I mean, and even educators. By the time I left, we had already had, I think, 3 or 4 educators that were part of the NASA Astronaut Corps. And those just represented the aspects that would conduct the missions in space. On the ground, you had engineers and researchers, scientists, business people, attorneys, administrative support, technicians. All of this made up NASA. And so the mission that we saw in that video happened not as a result of anything I did alone, nothing that we did as a crew together. It was a result of hundreds of thousands of people across our country coming together and working on something very, very important, each working within their own area of expertise, and then that being integrated to a much larger picture. So today, I thought, let's talk a little bit about AI and how I and even NASA participates in the AI space, in space. And we're going to talk about just a few applications. I will tell you, this is not inclusive of everything that NASA is doing in space. But I wanted to at least bring it to your attention to get you thinking a little bit about it. Because as we saw in everything in that video, there's lots of engineering equipment, a lot of data is being generated, lots of decisions are being made. Many of the decisions, by the way, were made by humans in the loop, which is very much open loop. And takes time away from the crew being able to do other things. This is where I think AI has an opportunity to augment the human space exploration experience. So, all right, so let's talk about a few areas here in AI. One area, pretty obvious, is robotics. We know we've seen robotic usage. I know Boston Dynamics does some really great work up in MIT, but there are some very specific robotic applications that are very unique to NASA's space program and the ESA space program. Data analysis, this should be pretty obvious given the fact that we have a world of data in all sorts of satellite instrumentation, whether you're talking about climate instruments or Earth observation instruments, and even deep space instruments. Many of us have seen just recently the amount of data that's been generated by the James Webb Telescope. In a short period of time, the data from James Webb alone will be more than what we currently have and all the other data produced by Hubble or any other science instrument, any other science platform in space, because James Webb is that powerful. And we're nowhere near looking at even the very first sets of images. Navigation, this should be pretty obvious for those of us, here living in Southern California. We see Teslas all over the place. And we see sometimes videotapes of people asleep behind the wheel of the Teslas, right? Navigation seems to be a pretty obvious thing. We'll talk a little bit about that. And then the last thing that we should all appreciate as well, given our proximity to Jet Propulsion Laboratory, and that is rovers. But a little bit more than just the Martian rovers. And I'll say a few words about that in a second. So first off, let's talk about what we currently have. On the International Space Station, this is a payload which was developed by ESA. The German space agency is the prime contributor to this. This is Simon 2. Simon 2 is a free-flying ball, basically, has fans that propels it inside the cabin of the International Space Station. And it interfaces with astronauts. So it has AI on board, which allows not only for Simon to be able to go out and conduct specific tasks. Think here, Alexa, Alexa, turn on the light. Well, Simon would actually go and potentially work on, let's say, biological experiments or what have you. The astronaut gives direction to Simon. Simon goes and does some work, comes back and reports to it, or collects data, or does whatever it has to do. Additionally, when astronauts go into space, they're in orbit for anywhere between 6 months to a year. And while you may have other crewmates that come up and visit you during that time, and you may actually have a crew that will be part of your crew that entire time when you're in orbit, Simon represents an opportunity for AI to actually take intonations from the dialogue of an astronaut communicating with Simon to be able to allow Simon to interpret the mood of the astronaut and to act as more of a basically to understand more than just the spoken word of the astronaut. This is being explored because if you want to go to the moon, the trip to the moon takes you about 2 days, give or take. That's a relatively short time frame. And if you have a problem and you need to come back home, you have an anxiety attack or what have you, the trip is not that long. You could power through it. But if you want to go to Mars, with existing rocket technology, it'll take you anywhere from 7 to 9 months to get to Mars. And then once you're on Mars, because of the orbital mechanics of the Earth and the Moon, you could be on the planet and not return back for 2.5 years, 3 years. So the Martian duration is a long time. NASA is already trying to think about what those problems might be that the astronauts would have to deal with. Not only do they need help, but also they might need help. And so this gives an opportunity for us to start actually working on payloads today to start to experiment on what those applications might be in the future. Robonaut 2, has anyone seen Robonaut at all? Anyone familiar with that? Okay, so Robonaut's actually a pretty interesting, and Robonaut 1 was actually just the first top part of this. And if you look at Robonaut, it actually looks kind of like an astronaut, right? The original design of Robonaut was actually to go outside the spacecraft and perform maintenance operations, just like you saw in the video where I was out there doing a spacewalk and messing around with hardware and doing some work outside the space station. Robonaut is supposed to be able to do. Now, unfortunately, much of Robonaut is all manually actuated. So you have to basically go in there and design the program to be able to perform a particular operation. In its functional sense, you would want it to have the same kind of interaction and intelligence that someone, or maybe lack of intelligence, someone like me, who's out there doing a spacewalk, and when I say lack of intelligence, because I'll tell you, you go out and you do a spacewalk, the first thing that your brain does is it shuts down, because you're above the surface of the planet going 5 miles a second. The blackness of space is out there. If you let go, you could potentially go drifting off into space. So it's very much an overwhelming experience. Nice thing about Robonaut doesn't necessarily get overwhelmed in that way. But still, there's lots of decisions that are made by astronauts that are real time. That is one of the reasons why we have this balance in our space program of both having robotic missions and human missions. I'll tell you a quick story. When I was trying to become an astronaut, I went in for an interview at Johnson Space Center. And as part of the interview process, it's a week-long process. We had a little social event. And at that social event, we met with all the older astronauts. And one of the astronauts I met with was a guy by the name of John Young. For those who don't know, John Young was the 6th person on the moon. And he's a crusty old guy, really nice man, but he's an Apollo-era astronaut. And so John is holding his beer, and I'm holding my beer. And I had been working at JPL at the time. And we had just landed Mars Sojourner, which is the Mars Pathfinder mission, the very first rover to land on Mars. I helped work on that mission. And so I asked John, I said, hey, John, what do you think about the rover out there on Mars? Because of course, we've never put anybody on the planet of Mars yet. And I asked him, hey, what do you think about the Pathfinder? Pretty impressive, huh? So John's this crusty old guy. He says, it took that rover 6 months, what it would have taken an astronaut 6 minutes to figure out. And that's true. Human beings can process information so much more quickly. And we even see now today, as we interface with the rovers on Mars, because of the delay and because we're worried about damaging hardware, we do it in a very gentle sort of manner. But suffice to say is that Robonaut 2 is a payload which now has actually legs that were attached to it that allows it the ability to actually climb and scamper, somewhat similar to the way that you saw the astronauts do in their spacewalks earlier. An area where artificial intelligence could benefit the operations. And even existing technology. What you see here, this is a robotic arm that's developed by the Canadians. This is on the space station, space station robotic arm. Attached to it is what they refer to as the SPITM, Special Purpose Dexterous Manipulator Robot. So this is one giant robotic arm, very similar to like the robotic arm on the space shuttle. SPITM is like a human. It has a center torso. It has 2 independent arms. And by taking the hand from the robotic arm and grabbing it from underneath, you can power this robot. And so now you have 2 smaller robotic arms, which can then perform tasks such as repairing and replacing avionics boxes, which are located outside a space station. Now, in the past, these robotic arms were all manipulated by the crew inside the space station. You may remember in the video, there's a Kevin Ford, who was our pilot, was in front of a bunch of monitors. He's pointing to the screen and he's got this big display in front of him. There maybe is a total of 8 or 9 displays that provide insight to the astronaut who are responsible for manipulating the robotic arm on the outside. And the reason for so many displays is because they're all camera views to try to make sure that you don't have a collision with the robotic arm during the manipulation. Now, the geometry is very well known, very well understood on the space station. There's nothing else out there that you're going to run into. But yet, when a human being is behind the controls, there's always that sense like, I better just check, better, double check, better triple check. Because of course, if you make a mistake, you could have a problem. And so we now have the ability to manipulate these robotic arms from the ground. We've actually evolved and learned how to have ground control teams actually perform the operations that the astronauts perform on orbit. Because let's face it, whether you're in the space station or whether you're in mission control, you still can't physically see the robotic arm because it's outside the space station, which means that whether you're controlling it from the ground or you're controlling it from space station is irrelevant, okay? Again, the geometry doesn't change. So these kinds of operations, I think, would be, key to be looking at for artificial intelligence application, because really that's what you're talking about, is bringing that insight that the astronaut would, or the ground controller would use to perform the robotic operations and providing that to the software system that actually does the manipulation. Okay, so data analysis. There's a plethora of data that's out there. There's more data that NASA has produced since the beginning of the program than has been analyzed. And there are these are ripe for analysis through artificial intelligence. Image processing, obviously, when we talk about image processing, we've seen some of that actually highlighted during the Ukrainian war. Being able to identify how things have changed in a very short period of time, whether troops are in one location or hardware's in one location, and how that's been moved, setting up, for example, temporary bridges, pontoon bridges. Lots of ways that image processing has been looked at, but a lot of that on a non-military basis is ripe for AI application. Climate change. This is a big deal. Even though we can't see it, we have instruments that can see things like ozone, things like CO2. They can see things, water vapor in the upper atmosphere, and all these kinds of things can be not only analyzed in their own individual silos of monitoring, but you can now start to integrate data across the different instruments to build a much more robust picture of how climate change is affecting, let's say, a certain region. So we can do things like look at the temperature trending across the planet, to be able to provide insight to the population, and to be able to forecast when you're going to have severe droughts well in advance. Things such as sea levels and deforestation provide direct information to those that are on the ground, people who are living in the coastal regions, or people who are potentially affecting the amount of runoff that occurs because of a result of clear cutting. This data has been available by NASA for many, many years, and also provides an opportunity for being able to take pieces of this information and start to integrate them together and allow computational technology to take over where human beings have had to digest this information in the past to try to make sense of it. Okay, and we saw a little bit of this. This is the way we actually rendezvoused with the space station. You would have one person holding a laser rangefinder, reading those, and that was me, but this is not me, but this was my job on both of my missions, was to basically say how far away we were from the space station. Now, why is that important? Well, as you get closer, you want to be going slower, so you want to look at your trends. And you had the pilot who was responsible for trying to fly the space shuttle up to the space station. And then you also have to take into account things like orbital mechanics and the amount of propellant that you're using, and all this data is just information overload for any one person trying to rendezvous at the space station in the old world. So as you might have guessed, as time has progressed, we've been able to take a lot of that data and integrate it into a platform which allows the astronauts to be able to fly a little bit more comfortably, but it's still not closed loop, still very much open loop. The intent is to be able to have a fully autonomous, docking and rendezvousing capability. And these are things that NASA is actually exploring. So this is an experiment that was run on International Space Station. This was a few years ago. Ames Research Center is the one who created the AI behind the SPHERES program. SPHERES, I can't remember what the acronym is, but it includes things, basically rendezvous and docking, station keeping, formation flying. They've recently done some additional work to look at things such as what's referred to as, it's called satellite slosh, or no, fuel slosh. Okay, so think here, if you took one of these spheres and you actually turned it into a tug, and you came up to a defunct satellite, that you want to be able to take that defunct satellite and tug it down into an orbit that'll allow it to decay and burn up in the upper atmosphere. If it still has propellant inside the tank, as you start to tug it, you get this slosh that occurs if there's any residual fuel in the tanks, which can cause all sorts of perturbations in the movement of that satellite to a lower orbit. So this program was actually flown in the mid 2010s. I think it's still an active program as well, but AI is incorporated on board to basically take over some of the responsibilities in rendezvous and docking that astronauts had to do back in previous missions. And the idea is to basically make these things free flyers so they become more autonomous, similar to what we see in the Teslas that are driving down the freeway with the driver asleep, although hopefully the astronauts are not asleep. Okay, exploration rovers. This should be pretty obvious. It takes about 20 minutes to be able to send a command from Earth to Mars. And so by the time you get the photograph that your Martian rover is going over a cliff, is probably the wrong time to send the command to stop moving. So you want to have more and more intelligence being built on the platform itself to allow the rover to make decisions for itself. Okay, that's a pretty obvious one. A less obvious one is, let's say you have an astronaut who is exploring the moon. I've got two dogs. I have a husky and I have a mixed terrier, and I love my dogs. And if I took a ball and I threw the ball, my husky would go chasing after it, and she'd go pick it up and she'd bring it right back to me. And just think about how great it would be for an astronaut to be able to have a robotic dog with them on the moon. Not necessarily go chase, you're not going to throw a rock out there and have them go chase the rock, but maybe look for some very specific samples. So while the astronaut is busy doing one type of activity, a rover that has the ability to do and process information in the same way that the human being could process the information, to look for specific types of rocks, specific type of minerals, specific type of information, or maybe even retrieve tools, to be able to bring those back without being commanded. And these are realms of possibilities in future AI applications. Okay. So we've talked about a number of different types of AI applications in space. But I think one thing that has to be appreciated is that space is a unique place. It's unlike anything we have here on Earth. And so there are some considerations that need to be taken into account. And this is where I'm hoping that we might have an opportunity to work with EMAL in the future on some potential applications. So I thought when you're out there doing a spacewalk, it's an overwhelming experience. As I said, you look down below and the Earth is just zipping right by you. Things are moving in directions like you have no frame of reference as to what is up, down, left, or right. You're only closer to or further away from things. At any given time, regardless of what you see out of your visor, you're always upright. So the Earth is either upside down or maybe below you or above you, and space station has all these different angles. And so I thought, just for fun, I would share with you what the view looks like from doing a spacewalk, to kind of give you an appreciation for, or get you thinking a little bit about, where might there be some potential applications for AI in space. Let me get this going here, see if I can get it to work. Now, there are a lot of lessons that I feel like I learned in space. I think the greatest lesson that I learned was that there's a lot more that we can do. There's a lot more that we can learn. One of the reasons why I love working in space is because it's all about the possibility of what human beings can do when they put their mind to it. Now, today I've not tried to cover the whole breadth of all the possible applications of AI, and I'll confess, I'm not smart enough to be a computer scientist. But there are applications, I believe, for artificial intelligence and machine learning that can help enable a much more robust space program. We've not even discussed things such as the applications in the medical fields and how that could benefit the space endeavors, especially for going to Mars and in the moon and beyond. But suffice to say is that I do believe that there are great opportunities that are out there, and I look forward to sharing with with the center and learning from the center and seeing where the those opportunities might be. So I want to thank you for your time, and I'm happy to answer any questions that you might have. I don't know that I have all the answers, especially with regard to some of the payloads, but I'm more than happy to answer any questions that you might have.
Thank you.
Anybody have questions for Daniel?
I have one, but it's not exactly related to the presentation.
Okay.
I would like to hear if you ever had like a very dangerous experience in space. And
Okay, so I'm going to challenge the artificial intelligence community. Okay, and I'll tell you why I believe that, because I get this question all the time as to whether or not I'm scared of artificial intelligence, or whether or not I feel threatened by it. Okay, on STS-117, this was in 2007. It was my very first mission, so I was a rookie. We blasted off the planet and we got into space. And when we opened up the payload bay doors on the space shuttle, we looked in the back and there was damage on the space shuttle itself. Now, this was the 5th flight after Space Shuttle Columbia. For those who don't remember, in 2003, Space Shuttle Columbia broke up over North Texas because when Columbia came in, unbeknownst to the team, going uphill, going into space, a piece of foam came off the tank, punched a hole in the wing. And so when Columbia came back home, we didn't know the hole was there. When Columbia came back home, hot gas went into the wing, destroyed the wing, and we lost the vehicle. We lost all 7 crew members. Everybody died. Okay, so this was about the 5th flight afterwards. When we opened up the payload bay doors and we saw the damage to the thermal protection system, we immediately knew that we had a problem and we didn't know what we were going to do about it. After Columbia happened, NASA spent a lot of time and a lot of money trying to fix the problem that damaged Columbia. So we came up with all these wonderful repairs, but the problem is that the repair techniques that we came up with were never designed to be implemented on the place that had been damaged. So we said, okay, you know what? Let's just do our work. So we took a bunch of photographs. We sent that information down to the ground. Said, you guys, good luck. Let us know. Let us know what to do. We're going to go back to work and we're going to try to figure out what we need to do to fix this. Now that had to be repaired before we came home. Up in space, it was okay because we didn't have to worry about the hot plasma entering that hole in the thermal protection system. So we went to work, no problem. Flight day 6 comes along. Now I've already done my first spacewalk. I'm still a rookie, and this is my first flight. I'm getting ready to go out to my next spacewalk of the mission, and we get the call from the ground. And the ground says, "Hey, we have a solution for you. We want you to go repair the space shuttle. We have a repair technique that we think should work." Like, okay, so why don't you tell us what we need to do? They said, well, first we need you to go to the flight medical kit and take a stapler out of the medical kit. So basically, we were having to repair the space shuttle using medical devices. Okay, we talked about including the diverse thought. The guy who came up with that solution was actually a flight surgeon. Anyway, so we get this call, says go get the stapler, go get this, go get that, and here's the procedures. And then they said, okay, Danny, we want you to do it. And I was like, okay. And it turns out the reason that they wanted me to do it was because I was familiar with the material systems, the thermal protection systems. Actually, after Columbia, that team that developed those different repair materials, I was one of the engineers who actually worked with them to come up with those different repair materials and techniques. And so on flight day 7, I had the stapler, had all my gear with me, and I proceeded to go out there and do a 3-hour spacewalk. So if you can imagine out there doing a repair to the space shuttle, thinking to myself, okay, if this is my second spacewalk, I'm fixing the space shuttle that's never been damaged this way before with materials that we never thought we would ever have to use. And oh yeah, by the way, it's got to get us home without without failing along the way. So I would say that was a pucker moment. I was, it was probably the most stressful situation I had on orbit, because I knew that at that time that the responsibility of getting it right was on me. And even though they had done all the testing and all the evaluations, and they'd come up with the procedures, it boiled down to what was I going to do at that point. And so the challenge to the AI community was that, okay, here was this hole, okay? And I was told by the ground, they said, hey, look, we've tried to look into that hole and we can't determine what the substrate is. You know, we need to be able to see in there. And I said, and so I'm out there, and they said, when you go out there, turn your flashlights on your helmet, and because we had cameras on the helmet, I said, look into the hole and see if you can illuminate it so we can see what the substrate is. We need to see if there's any damage to the substrate. So I went out there and I'm using my flashlights, and they're like, we can't see anything. Of course not, because we had the sun basically bouncing off the white blankets of the space shuttle. And so we had camera bloom going on, and you couldn't see anything in the cameras, and you couldn't see anything in the little cavity. And I was talking to my crewmates over the radio, and he said, you know, Danny, we need you to tell us what you see inside there. But I had no idea what I was looking at, because I had never worked in this area before. I didn't know what I was trying to describe. It wasn't working. And then I thought, well, they got to be able to see in there. So what are my options? My helmet lights don't work. And I looked up at the sun and I said, I know what. So it turns out if you do a spacewalk, everything that you need is on your back, right? Your air's on your back, your water's on your back, your fan's on your back, everything is on your back. It's called a primary life support system. The way you interface with everything that's on the back is through a computer in the front, okay? But you can imagine if you're in a spacesuit and you're trying to look at a computer, you know, that display and control module is actually on your chest, so you can't really see it that well. And all the buttons and switches are all in the front. So the way that you interact with that is, NASA's really smart. They actually wrote all the controls backwards. And the way that the astronauts interface with that is through mirrors on their wrist. So you have these little mirrors that you put on your wrist, and you use the mirror to look at the control, and then you can manipulate the control with the other hand. And so I looked up at the sun, and I looked at my mirrors, and I said, I know. So I bounced the sunlight off of the mirror and down into the cavity. So it helped the ground see what was there, and that all worked out great. But then this kind of goes back to, you know, the human experience and how much computers can really, how much can computers really do? And I wonder, will we ever get to the point where computers will be able to make that decision on the spot to be able to provide the information the ground needed? You know, the only reason I knew to do that is because I did that in my professional experience as an investigator. I used, you know, light and mirrors, bouncing light off of all over sources, all sorts of in all sorts of cases. So it's like I had that experience, but I wonder, even if I had all that information provided into a computer, would a computer come up with that solution? I don't know, maybe you guys can tell me. You guys can tell me.
Currently, no, probably.
My question was about, do you think that NASA or any other space agency is welcoming in terms of like allowing experts in AI? Because we see like when we hear about the kind of AI being used on space, it does seem quite behind, I guess, as opposed to all the other AI that's going on in the rest of the world.
Yeah, so, and I appreciate you asking that question. I also am a board member of the NASA Advisory Council. And your question was answered about 2 weeks ago, because one of the things that we were lamenting was how much data was out there that NASA has produced over in all these various areas, by the way. And the one thing that we have not been good at is actually accessing computational capacity and capability in analyzing the data, and not just on orbit, but, you know, even the data that's available right now, and being able to apply it to help us solve some of these problems, or at least become more aware of how some of these things that are happening on, for example, within our within our environment, our climate, how these things are interacting with one another, and what changes can we do, and what changes can we make, and how things can manipulate and affect other variables within the system. And like I said before, in the past, what NASA has done is basically they have a bunch of climatologists who basically go through reams and reams of data, and they produce a few graphs, but for the most part, I don't think, fully accessing the full power of AI and computational technology. And really what it is, it's about data, being able to assimilate the amount of data that's out there. And we are underutilizing the data that we have available to us. And with every instrument that we fly, we get more and more data. So I do think that there's an opportunity in being able to bring in AI. And certainly in some areas are far more mature and ready and able to accept that information. Others have to grow and evolve depending on mission objectives for NASA's overall objectives, like for example, going back to the moon and whatnot.
Thank you. That was inspiring.
Thank you very much.
Thank
you very much.
I just want to say something quickly to my students and all the students here. A few weeks ago, I shared with all of you a video from 2012 with Jeff Bezos, where Jeff Bezos was interviewing with Charlie Rose, and Jeff Bezos was basically telling him, I want to go to space. And then 10 years later, Jeff Bezos actually went to space. But Jeff Bezos is a billionaire and he can go to space. This is a human being who actually went to space by education and by dreaming big and working hard and never giving up. So, thank you.
All right, thank you.
Thank you. That was inspiring.